So welcome everybody to this latest video on 162 Maths, and in this video we'll be continuing with the series of going through some big mark questions taken from some past GCSE Maths higher exam papers. Now as always there'll be a copy of the questions for you to have an attempt at before watching this video as we go through the answers, and I'll also include the mark scheme for in case you've found a different way of getting the same answer. Now, if you not have the opportunity to print off any of the questions, then all you need to do is to simply pause the video as I read out the question and then unpause to hear the answer. So before we get started, let's just have a quick glance at what topic each of the questions are. Now, unlike some of the previous big mark question videos I've made, these questions are quite unique to specific to one topic, which is quite nice. So, and just a little reminder that although I've kind of guessed at which questions will be on a calculator and non-calculator, with the ones on the non-calculator they could easily appear on a calculator paper because not every single question on a calculator paper requires a calculator. So it was just a case more of that I didn't actually personally need a calculator to answer that question, which is why I've deemed it so. So enough of me battering on, let's have a look at question 1. Now again, if you've not had opportunity to or the facilities to print off any of these questions for you to have an attempt at, then all you simply need to do is just simply pause the video and have an attempt at the question, then unpause and see if you got the same answer. So let's have a look at question 1. So question 1 says the area of this triangle is 18 centimeters squared and we need to work out the value of y. Now no information is kind of given fruitlessly, so with this we need to ask ourselves, why have they given the area of a triangle? So for this is because I need it to work out what one of the letters are. Now because this is a non-right angled triangle and I haven't been given the perpendicular height, I'm going to have to use that the area of the triangle is equal to a half AB sine C. So labelling this triangle, I'm going to label this as C, this is going to be A, and that's going to be B. So from this I should therefore then be able to work out what W is. So looking at this, let's have a look. So we've got half times W times 2W times sine 30, which is an exact value of trig, and that equals 18. So from this, if I do a bit of rearranging, we get a half times 2W squared, and sine 30 is an exact value of trig, which is a half. So then if I either combine the two halves to make a quarter or just take the 2's over separately, then what I end up with is 2w squared is going to equal 72. So then w squared equals 36. So w is therefore going to equal positive 6. Now you could be tempted to write plus or minus 6, but because W is the length, it can't be a negative number, so it's going to be 6. So once I've calculated W, I can then work out the lengths of this, so that's going to be 6 and this is going to be 12. So now looking at the triangle, let me just do a little sketch of that triangle again. So here's Y, that's 6, that's 12, and this is 30. So from this, what we can then do is use the cosine rule. So I've got Y squared equals 6 squared plus 12 squared minus 2 times 6 times 12 times cos 30. Now cos 30 again is another exact value of trig, so I've got y squared equals 36 plus 144 minus 2 times 6 times 12 is going to give me 144, and that's multiplied by cos 30. So then y squared equals, then combining these two numbers here, I'm going to get 180, and then I've got minus 144 times root 3 over 2. Now at this stage I've probably then assumed that this is going to be on a calculator paper, even though we've got exact values of trig ratios here. So I've got y squared is going to equal 180 minus 72 root 3, and then I'm just going to simply type that all into my calculator. So I've got 55.2923. Let's make that decimal point a little bit clearer. And so therefore y is going to equal the square root of that number, which is 7.44, and that's to 2 decimal places. Moving on to question 2, we've got another trig question. So here it says that the diagram shows a cuboid A, B, C, D, P, Q, R, S and a pyramid P, Q, R, S, V, and V is directly above the centre X of A, B, C, D. The total height is Vx is 5 centimeters, 5 meters rather, and work out, and the first part of the question is asking us to work out the angle between VA and the plane ABCD. So for this, what you want to do is kind of highlight each of these areas. So V to A is going to be this line here, and the plane ABCD, if I use one of the highlighters, is going to be basically this bottom square. So basically what it's asking me is to work out the angle that connects. So the angle that it connects with is going to be this angle here. So that is the ultimate prize that I'm actually wanting. So for this, I need to work out what AX is. Well, I can't work out what AX is, but I can work out what AC is. So if I take that triangle out, that base triangle, and just label this so it makes a little bit clearer of what I'm doing. So AC and B. So then I've got 10. And I know that that is 6. So this here is A to C. So AC squared is going to be 36 plus 100. So AC is going to be the square root of 136. Then if I want to work out what AX is, which is half of that, so it's going to be root 136 divided by 2. And that gives me an answer of root 34, or the decimal equivalent, which if I reach for my calculator is 5.83 blah blah blah. So if I just write that in brackets, 5.83 blah blah blah, but I'm going to leave it as root 34 because that's quite a nice way of writing it. So looking at that second triangle, which is A, V and X, I know this length here is root 34. And I know that the height is 5, and this is the angle that I'm trying to find, which I'm just going to call, actually let's not call it X, let's call it theta. Now it doesn't really matter what you call it. So here we're going to use tan, so we've got tan theta equals the opposite over the adjacent. So theta is going to equal inverse tan of 5 over root 34. And if I put that into my calculator, I should get an answer of 40.6 degrees, and that's to 1 decimal place. So then moving on to question B. The question B then says work out the angle between the planes VQR and PQRS. Struggling to read my alphabet there. So let me just start by getting rid of all of this. And like I said, what we want to do with these types of things is to highlight what it is we're actually got to find, because it definitely does make it, because within this diagram there are a lot of angles we can find, and certainly a lot of sides we can find as well. So let's have a look at what it is. So VQR is basically this triangle here, which I'm going to have a rather poor attempt at trying to colour in. And the plane PQRS is basically this rectangle here. So I want to work out the angle that is connected between those two sides. And what that is, it's basically going to be this angle here. So if I imagine a midpoint, this is the angle that I need to find, which I'm just going to call X. So from this, if I just find the sides, well, this base of the triangle is going to be 5 because it's half of 10. And I then need to work out this height, which is going to be 5 take away 3. So that's going to be 2. So for B, what I'm looking at is I'm looking at this triangle here. This is the angle I need to find. This is 5 and this is 2. So again, I'm going to need to use tan again. So I've got tan X equals 2 over 5. So X equals the inverse tan of 2/5. And if I type that into my calculator, I should end up with an answer of 21.8 degrees, and that's to 1 decimal place. So moving on to question 3, looking at box and whisker diagrams or box plots. It says girls and boys are timed in a race. The box plot shows information about the times for the girls, and here we've got it, and it says 25% of the boys take 12 seconds or less. The interquartile range for the boys is the same as the girls, and the ratio of the median time is girls to boys is 8 to 7. So looking at this first bit of information, the question is asking me to complete the box plot for the boys. So 25% of the boys take 12 seconds or less, so that's going to be the lower quartile. So my lower quartile is going to be here. The interquartile range for the girls is 4. So, and again, if I just go up there, because it's going to be 13, take away 17, which is 4. So that means that the upper quartile is going to be at 12 plus 4, which is 16. So there's my box. Again, you should be really using a ruler, but I'm going to be a little bit lazy. Now here, the median for the girls, if I look at the above diagram, is at 16. Now looking at this ratio, that equals 8 parts. So then 1 part is going to equal 2, and then 7 parts is going to be 2 times 7, which is 14. So that means that the median value is going to be 14, and then what's left for me to do is just simply draw my whiskers with a ruler, preferably, but I've cheated there, and there we go. Moving on to question 4, it says that a shelf supports 80 kilograms to the nearest kilogram, and bottles weigh 1.4 kilograms each to the nearest tenth of a kilogram. Work out the greatest number of bottles that can definitely be supported by the shelf. So first things first, you always want to state the upper and lower bounds for each of these. So for the shelf, it's going to be 79.5 to 80.5, and for the bottles, it's going to be 135 to 145. And again, you always want to state that. Now, so going back to the question, we want to know the greatest possible number. So the greatest most is going to be, so we're looking at the worst case scenario. So the worst case scenario is going to be a light shelf and heavy bottles. So the lightest shelf is going to be 79.5, and the heaviest bottle is going to be 1.45. So if we divide that, and if I type that into my calculator, I get an answer of 54. Then moving on to our last question, it says find 2 sets of values for C and D such that, and we've got, so here we'll just write it a little bit bigger. We've got 16 to the power of C equals 2 to the power of D. I'm writing 2D4. Now with this, what you want to try and do is get the base numbers the same. So I can notice that I can write 16 as 2 to the power of 4. So then 16C then becomes 2 to the power of 4 to the power of C. And then when I've got brackets, I can multiply. So then what this then becomes, 16C equals 24C. So swapping that, what I do is I get 24C equals 2D. And then from this, what I notice is that if the base numbers are the same, then the powers must equal. So I've got 4C equals D. Now for this, all I need to do is just make up a number for C and work out D. So you can pick absolutely any number for C, but I'm going to keep it simple. So when C equals 1, D is going to equal 4 times 1, which is 4. When C equals 2, D is going to equal 4 times 2, which is 8. And again, you can pick any number. So I'm just going to go for 1 and 4 and 2 and 8. You could pick absolutely any number as long as whatever C is, you multiply it by 4 to give you D. And you can literally go as much as you want. You could go for 10 and 40, 100 and 400. You could go for 2,000 and 8,000. It really doesn't matter. 8 million to 2 million. Again, it's entirely up to you. So infinite number of possible answers for this one.